Ever wondered why some medical scans look blurry or distorted? Those weird lines or shadows. They're called artifacts, and they're a huge problem in healthcare. Artifacts can mess up diagnoses, making it hard for doctors to see what's really going on. But here's the thing. Traditional methods for spotting these issues are, well, kind of clunky. They often lose important details during processing and need way too much memory. Not great when you're dealing with huge medical images. So what's the fix? Let's talk about implicit neural representations, or INRs for short. Think of INRs as a smarter way to store images. Instead of pixel by pixel, they use mathematical equations to describe the whole picture. It's like having a blueprint instead of a photo. This makes them super efficient, handling different sizes and resolutions without losing quality. Plus, they use way less memory. Cool, right? Now here's where it gets interesting. Researchers took this INR idea and applied it to assess image quality in cardiac MRI scans. They generated synthetic artifacts by messing with the case-based data, basically the raw information that gets turned into images. By swapping frequencies between heartbeats, they created images with varying levels of distortion. Then they trained models to spot these issues directly from the INRs, not the original pixels. The results? Their system matched traditional methods but used way fewer parameters, like 14 times fewer. They tested different AI models, from simple neural networks to fancy transformers, and found that INRs could classify image quality just as well. The key takeaway? This approach is faster, more scalable, and keeps more of the original data intact. Why does this matter? Better image quality means more accurate diagnoses. Imagine a world where AI helps doctors quickly spot problems in scans without getting tripped up by artifacts. That's the future this research is paving. But here's the real kicker. INRs don't just detect artifacts, they can predict image quality with astonishing precision. A 2023 study showed that by training models on synthetic case-based data, researchers could classify scans as good or poor, with 91.8% accuracy. Even more impressive, they achieved this with models that had 14 times fewer parameters than traditional pixel-based systems. It's like replacing a 12 million parameter neural network with a lightweight 384,000 parameter transformer. Now let's talk about how this works. INRs encode images into mathematical functions, capturing complex patterns more efficiently. Think of it as translating a photo into a set of equations. This allows the model to analyze the image's structure without relying on pixel-by-pixel data. The study found that even early training steps, like just one iteration, could already guess image quality with 90.8% accuracy. But the sweet spot? At 29.85 dB, a measure of clarity, accuracy peaked at 91.8% for good vs poor scans. Pushing further to 31.07 dB. Accuracy dipped slightly. It's a Goldilocks zone. Too little training and the model misses details too much and it overfits. This isn't just about detection. Researchers are exploring how INRs could fix blurry images by editing the neural representation itself. Imagine an AI that doesn't just flag a distorted scan, but actively restores it. The implications are huge: faster processing, lower memory usage, and real-time applications in hospitals. But there's a catch. INR optimization is still computationally heavy, and the study used synthetic data, which might not fully mimic real-world chaos. Still, the results are a huge step forward. From reducing metal-related noise in pacemaker patients to teaching AI to think like experts, these innovations are pushing medical imaging into a new era. The next time you see a heart scan, remember, behind the scenes, scientists are using AI to turn blurry, distorted data into life-saving clarity. And that's just the beginning. These tools are already being tested in real hospitals, helping doctors make faster, more accurate decisions. Science isn't just about big discoveries. It's about solving real problems, one pixel at a time. Stay curious, and we'll keep exploring the stories behind the tech shaping our future. Ever wondered how doctors tell if an MRI is clear or blurry? Or why some medical images get flagged for quality issues? Today, we're diving into a groundbreaking approach using implicit neural representations, or INRs, to assess image quality in ways that could revolutionize medical imaging. Let's break this down. So, traditional methods for evaluating MRI quality often rely on pixel-by-pixel analysis. But here's the problem. Raw pixel data can miss the bigger picture. Think of it like trying to guess a song by only hearing a single note. That's where INRs come in. These are neural networks that encode entire images into mathematical functions, capturing complex patterns more efficiently. It's like having a blueprint of the image, not just a snapshot. The study we're looking at explores how INRs can classify image quality, like distinguishing between good and poor scans. They found that early stopping during training is key. Imagine training a model to fix a blurry photo. If you stop too early, the image is still fuzzy. But if you train too long, something strange happens. Accuracy actually dips. It's like over-polishing a painting and losing its original charm. Here's the cool part. Even after just one training step, INRs can already guess image quality pretty well. At 14.97 dB, a measure of clarity, they hit 90.8% accuracy for good versus poor scans. But the best performance? That's at 29.85 dB, where accuracy peaks at 91.8% for good versus poor and 80.4% for good versus mid. However, pushing further to 31.07 dB. Accuracy slightly drops. So there's a sweet spot. Too much training isn't always better. Now, how do INRs stack up against traditional models? The researchers tested a giant pixel-based MLP with 12 million parameters and found it lagged behind. But lightweight INR models, they crushed it. The transformer-based INR, with just 384,000 parameters, achieved 94.4% accuracy for good versus poor scans without needing a massive computer. It's like comparing a luxury car to a sleek electric vehicle. Both get you there, but one uses way less fuel. Why does this matter? Well, medical imaging deals with huge datasets. INRs reduce memory and computational load, making them perfect for real-time applications. Plus, they're not just good for classification. They could one day help fix blurry images by editing the neural representation itself. But there's a catch. INR optimization is still computationally heavy, and the study used synthetic data, which might not fully mimic real-world chaos. Still, the results are a huge step forward. So what's next? Faster INR training for real-time use, broader dataset testing, and even exploring if INRs can correct artifacts instead of just spotting them. The future of medical imaging might not be about more pixels. It's about smarter, more efficient neural blueprints. Thanks for watching. If you're curious about how AI is reshaping healthcare, hit subscribe. Have you ever wondered how doctors get such clear images of the heart, even when there are metal devices or movement messing things up? Well, researchers are using cutting-edge AI to tackle these tricky problems in cardiac MRI scans. Let's break down how they're making breakthroughs that could change medical imaging forever. One big challenge in MRI is something called artifacts, those weird distortions or noise that can hide important details. Think of it like a blurry photo where you can't see the subject clearly. For patients with heart devices like pacemakers, these artifacts are even worse. But a 2023 study found a way to reduce these interference patterns using smart algorithms. By training AI to recognize normal heart structures, the system can essentially guess what the image should look like, even when parts are scrambled. Another team took a different approach. They explored how AI models learn from data. In 2024, researchers discovered that changing how neural networks process information, like tweaking their internal rules during training, can make them better at handling messy images. It's like giving the AI a better set of tools to fix errors, rather than just showing it more examples. This could mean faster, more accurate diagnoses without needing hours of extra data. What if we could teach AI to see like a human? A 2020 study introduced a trick called Implicit Neural Representations, where AI doesn't just memorize images, but learns the underlying patterns, like the way heart muscle contracts. This lets the model fill in gaps or correct distortions, almost like a painter restoring a damaged masterpiece. And when combined with other techniques, like simulating different patient movements, these models become super robust. From fixing metal-related noise to teaching AI to think like experts, these innovations are pushing medical imaging into a new era. The next time you see a heart scan, remember, behind the scenes, scientists are using AI to turn blurry, distorted data into life-saving clarity. And that's just the beginning. These tools are already being tested in real hospitals, helping doctors make faster, more accurate decisions. Science isn't just about big discoveries. It's about solving real problems, one pixel at a time. Stay curious, and we'll keep exploring the stories behind the tech shaping our future.